Anchor is the easiest way to make a podcast. Anchor gives you everything you need in one place for free, which you can use right from your phone or computer. Creation tools allows you to record and edit your broadcast so it sounds great. And they even distribute your broadcast for you so that it can be heard everywhere. Spotify, Apple Podcasts, and Google Podcasts. So make sure you download the Anchor app or go to anchor.fm to get started.
Hello, everyone, and welcome back to our math session. This is week number 3, and this is day number 5 for us. So we are still going at it. We will be doing this for your students who are struggling with math this school year to bring up their math score. So we will be helping your students out because we are future math teachers, and this will prepare us, get us ready for it once we enter our classrooms. So, yes. And as you can see in the background of Andrew's Frett, he has our logo in the back, which is very nice. Yes, I need to put that on mine as well. So yes. Or we need to put we probably need to make a logo for a math session. Like probably yours in the background, you have 6th grade and I have 8th grade. I don't know. We will figure something out with that. So we are going to begin off with Andrew.
Wait, hold on. Wait a minute. I'm back, y'all. Wait. Before it hit, you already jumping in. Hold on. I'm back. Hold on. And we're just not gonna act like I'm not gonna be here today. Okay, that's fine. But yes, I am back in case nobody has seen me already. But yeah, I'm back from Monday, from last week. From when was the last Friday?
Friday.
We did Friday. What? Friday?
Friday was...
You did the lesson on Friday, right?
Correct. And you wasn't here because Friday was 9/11.
Oh, Friday was 9/11. Okay. See, this is what happens when your days are mixed up. All right. So, in case y'all didn't know, I was not here on Friday. Sorry to my 6th graders. I'm sorry that I wasn't here on Friday because I went to honor 9/11. But I am back. I am back today. How y'all doing? I am back for the next 3 to 4 weeks before I leave again. I'm not going to tell you where I'm not tell you when I'm leaving. But on Monday, October the 5th, I will not be here. Or not Monday. Friday, October the 5th, I will not be here. It's either... Let me check my calendar. Sorry. Let me check my calendar. Monday, October 5th, I will not be here. Because I am traveling. Let's just say that. I'm traveling. So I'm back for the next 3 weeks. All right. I'm done.
All right.
I'm done now.
So as for me, you guys, I will be on here all the way up until the 10th week. And then I will be out for 2 days. So I could be working on my other podcast that I have to prepare for that. So I will be doing this for the next 10th week, and then I will be out, and then I will return back during the 11th week. So That's the schedule right there.
11. Yeah. Uh, yeah, 11th week. That is correct. Trying to look at my calendar here. I'll be here until once I get back on Monday. I'll be here until day 14, and then I'll be out on day 14 and day 15, and then I won't return back until that final 8th week, that Friday, October 20th. Am I going to be out October 3rd? Oh no, I'm sorry. I'm gonna be out both of those 8th week. I'll be back. I won't return until the 9th week. So once I leave for the beginning of the 6th week, once I return on that Friday the 9th, I have two to 3 weeks, two to 3 weeks, and then I'm leaving again. But only this time I'm taking my vacation. So all right. So let's get started, shall we? Because we got like 30 minutes left. So we should get started.
Yes. So let's get started because we're here. So
We're here. Anyway.
So let's start with you first, since you have a short lesson and I kind of was quite short, but I'll probably make it long. So to get yours at more, just since yours is quicker, let you go first today.
Okay. Like I said, hi y'all. If you missed me, I know I missed y'all too. From being on Friday, but on today, we're gonna talk about we're gonna go back to our regular scheduled programming, which was we're gonna talk about order, pairs, and relations. How exciting! Yes, it's exciting. So let us wrong thing, share screen. We are going to do this, share, and here we are. All right, so today we'll talk about order pairs and relations. My phone blowing up at the moment, but today we're going to talk about order pairs and relations. There will be a part 2 of this on Friday. Because I forgot one piece of information that we will get to on Friday. All right, so make sure you have a pen, make sure you have a pen and pencil. On standby.
Today's Monday. Today is Monday.
Yeah, it is Monday. Yes. Have a pen and pencil nearby because you will be taking notes. And trust me, you'll be taking notes. Today will be a short lesson as well. Like I said, there will be a part 2 of this because I forgot one piece of information, which is domain and range. Which, fun fact, you will learn more about domain and range once you get into high school, where you're going to be learning about parabolas. Yes, half of a circle. So you need to know how to find domain and range and stuff like that. Because once you get in high school, you got to be on it. Like it ain't nothing. All right, so today's vocab is, there are 1, 2, 3, 4, there's a whole lot of vocab. Ooh, y'all not supposed to see that. All right, so the corner of the plane is used to locate points and is formed by the intersection of 2 number lines that meet at right angles at the 0 points. When I think of corner planes, I think of side roads, you know, that crossroads. Think of it as that way, because each intersection has a stop sign, right? So that's kind of like relating to a corner plane because it's formed by the intersection of two stop signs. on each side. Where a coordinate plane is formed by the intersection of two number lines that meet at the right angle at 0 points. Order pair, y'all know what order pair is. Just look at any point on the coordinate plane. The x coordinate is going to be your first number. The y coordinate is going to be your second number. The y axis is going to be the vertical. The y, hold on. The y-axis is going to be the vertical number line. The origin is the point, should be the point at which the number lines intersect. The x-axis, the horizontal number line. And as an example right here, you have the y-axis, which is in purple, 1 through 8, and you have the x-axis, 0 through 8. So, I believe I can scroll this down. Okay. So for example, we have 2, 7. So the x coordinate, which is 2, is going to be x-axis. So we're going to move over. Let's hope I don't have any technical difficulties today. What color should I use? Okay. Okay. So the x coordinate equals x-axis. So we're going to move over 2. Okay. So that's where we're at right now. So I'm going to draw a huge circle right here. All right. Then 7, which is here, y coordinate equals y-axis. So we're going to move up 7, which is here. So I'm going to draw another circle. Okay. That's how, put a period or something, preferably a period once you get to that point. And that's how you find, and that's how you find 2, 7, right? Like I said, it's pretty easy, pretty easy. It's simple. All right, so I'm gonna do an example. Let us find 7. Let's do 7, 5. Okay, so we'll locate 7, 5 on the corner plane. So what we're going to do first is we're going to find the x coordinate, which is 7. So we're going to go over here. We're going to start at 0, and we're going to go all the way to 7. Then, once we do that, we're going to go up. Draw a little arrow here. We're going to go up 5. So 1, 2, 3, 4, 5. Once we get to there, we can put either a period. Let's put a period there. Okay. Okay, and then I'm just write E1, because this is example 1. Okay. I'm gonna do another example. All right. I'm gonna do another one because I feel, just in case people don't get it. Damian, give me a coordinate plane. Give me a order point, order pair. Excuse me.
Six, 5.
6, 5. All right. So we're gonna find 6, 5. All right. So what we're going to, oh my goodness. So what we're going to do first, we are going to find, I'm going to put in a couple of them. So what we're going to do first is, I'm going to do this in red. So we're going to go, we're going to find this first, which is 6. So we're going to go all the way over here to 0. And then we're going to go over 6. Once we go to 6, actually, let me draw a little arrow here. There we go. And then we're going to go up 5. So we're going to go 1, 2, 3, 4, and 5. We're going to put a little period here, and that's how you find a coordinate plane. Pretty simple, right? Yeah, I know. I think this is much easier if you draw. Ooh, that is not okay. I guess this is much easier if you draw arrows, if I can speak on today, to understand of what you're doing. To understand of what you're doing. So let me go ahead and draw arrows for these. So that way you will know how to X coordinate is to the left and Y coordinate is up. Actually, let me go ahead and write this down here. X axis is up. That should be a Y. And X axis is to the left. All right. Now, so that's 2 examples right there. I believe that is it. Yeah. So yeah, that is it. I told you this is gonna be a short lesson. So yeah, I'm pretty much done. Like I said, Friday there is another piece to this. There's a part 2 of this, which is you have to find domain range. Also going to learn how to do tables, words, and graphs all into one. So be ready for that. Also Friday, we are going to review everything that we have learned. So Friday, we're going to learn how to do word / variable, how to write variable expressions, word expressions, and how to solve GEMDAS. That's on Friday, and then next Monday is we're going to review this piece as well as the other piece as well, the words, tables, and graphs. So I'm gonna go ahead and stop sharing from here. So with that, I am done with my lesson. It took about 12 minutes. I told you it's very short, but there'll be another piece coming on Friday. But with that, I am done with my lesson for today.
All right. All right. That was a perfect lesson. Let me fix my screen because I'm quite on the opposite side. There we go. So great lesson. Great lesson. You finished in 18 minutes. Well, I mean, you had 18 minutes off. So now we're going into our mid-session break. We're just going to last for 10 minutes. So we are entering our mid-session break now. All right. So the 10 minutes are up now. I don't know if you guys uh, heard the calming music in the background, playing that in the background here. I don't know if you guys could heard it or not. Um, so let's get started with my lesson here. I told you guys that last week was the final week of me doing decimals, repeating decimals, and I'm through with that. I'm not covering that again. So if you missed that lesson, it's on our YouTube channel. So now it's a new week, which means a new lesson. So today, for the next, I believe 2 weeks I have, is square roots and cube roots. So we are going to dive into that, 8th graders, because you will be talking about this. Trust me, when I was in 8th grade, we did this, and you will need to know how to do these. So let's hop right into my lesson here. So what I'm going to be showing you guys is a video. I'm probably going to do that now, or I'm probably going to wait, that explains this lesson into more depth. So let me share my screen and we will begin. All right. So 8th graders, I hope you have your notes out, your notebooks out, and your pencils out to take these notes here. So square roots and cube roots. Today, I'm just going to only talk about I'm only going to be talking about square roots today. So, and here's the notes here, square roots. So what is a square root? Well, a square root is the square root of a number is one of its 2 equal factors. And here is the example down here that they provide. Using symbols, for example, A is the square root of B if A squared equals B, okay? Let me, because this is important. A is the square root of B if A squared equals B. Remember that. So here's an example that they provide for us. The square root of 36 is 6. Since 6 times 6, and I don't know if you can see this, but this between here, this is a dot, or let me do it right. Oh, it's fun. But right here is, you see, they don't use a times. Instead, when you move up a grade level, they will start using this here. So you guys should know this, that 6 times 6 is 36. You should know your multiplication facts by now, 8th graders. So the square root of 36 is 6. Now, moving down, the positive square root is called the principal square root. And then you will mainly be concerned with the principal square root. We're not going to dive into that there. Now, note this right here. Note that, okay, well, this won't cooperate with me. Thought that was going to highlight. Note this right here. In fact, just forget it. Okay, a negative real numbers, they do not have square roots because any non-zero real number is positive when it is squared. So no number multiplied by itself will give a negative real number. And I will show you guys an example of that. Now, go down here, the symbol, and you guys cannot see this, but the symbol, okay. This symbol right here, you guys, it is called a radical sign, and it is used to designate the principal square root. And here's an example. The square root of 49 is 7. They use the square root. This is what you will be using. The square root of 81 is 9. Oh, let me go back here. The square root of 49 is 7. Why? Because 7 times 7 is 49. The square root of 81 is 9. Why? Because 9 times 9 is 81. So the square root of 49 is read as the square root of 49, just as I mentioned. So the number under the radical symbol is called the radicand. 49 and 81 are these numbers here. This vocab, excuse me. So I'm gonna give you time to write this all down here or take a picture of it. And then I have a video provided for you guys. And then I have some more notes after the video. And I believe this video is about 5 minutes, which gives us plenty of time. And you guys need to be paying attention to the video. And I will stop it from time to time to explain it. So I hope you have these down, and let's move on.
For my 6th graders, we won't get into square roots until, if I am not mistaken, until later on in the week. So it's kind of like a refresher, kind of like a sneak peek, because I will be teaching this later down this week. So make sure you get this down.
Yes, please do, 6th graders, please do. I'll have to search it up in a few minutes, so I give you guys time to write this down, 6th graders as well.
Oh no, I'm sorry. Well, yes. We're actually going to get into exponents, powers and exponents. And then a couple weeks after that, we're going to talk about negative exponents and square roots and cube. So we will return to this lesson again.
Okay, let me find this video here. So pay close attention, my 8th graders. Please pay close attention.
Fancy mathematics on a chalkboard, you'll almost always see a symbol that looks like this radical.
Can you hear it, Andrew? I just want to make sure, can you hear the video?
Yes.
Yes, okay.
A symbol, and this is used to the square root, and we'll see other types of roots as well. But your question is, well, what does this thing actually mean? And now that we know a little bit about exponents, we'll see that the square root symbol or the root symbol or the radical is not so hard to understand. So let's start with an example. So we know that 3 to the 2nd power is what? 3 squared is what? Well, that's the same thing as 3 times 3. That's going to be equal to 9. Correct. But what if we went the other way around? What if we started with a 9 and we said, well, what times itself is equal to 9? We already know that answer is 3, but how could we use a symbol that tells us that? So, well, as you can imagine, that symbol is going to be the radical here. So we could write the square root of 9. And when you look at this way, you say, okay, what squared is equal to 9? And you would say, well, this is going to be equal to 3. And I want you to really look at these two equations right over here, because this is the essence of the square root symbol. If you say the square root of 9, you're saying what times itself is equal to 9. And, well, that's going to be 3. And 3 squared is equal to 9. I can do that again. I can do that many times. I can write 4 squared is equal to 16. Well, what's the square root of 16 going to be? Well, it's going to be equal to 4. Let me do it again. And actually, let me start with the square root. What is the square root of 25 going to be?
Now, you guys ought to know what's equal to 25, which would be 5, of course. Now, if you guys don't know what these numbers equal to, well, then you guys need to practice your multiplication facts every single day, because you will be using these numbers, you guys, every day in your math class. So you got to know your multiplication facts. I'm sorry, you just got to know it. How did he get this 9? 3, like he said, 3 times 3 is 9. How did he get 16? 4 times 4 is 16. And then when he comes over here, how did he get 25? 5 times 5 is 25. So you got to know your multiplication facts. All right, so let's continue.
Well, this is the number that times itself is going...
Before we...
Go ahead.
Before we continue, I'm not singing the same strain as you. I hear it, but I'm not seeing the same screen.
Oh. Okay. Okay.
Sorry to point out there. Also, while he's doing that, yeah, y'all should know y'all times tables. If not, then I don't know what y'all been missing out. Because it's really important. Also, you will need to know how to write, how to do a square root, because once you get to high school, you're gonna have to learn the distant formula.
Yes, absolutely, you guys. So if you guys have not learned your multiplication facts, which you should have starting your middle school years in 5th grade or even earlier than that, you need to know them now. Okay, it's very important. It's very important. So let me go back to this video, and hopefully you guys will be able to see it. I didn't know that it was not showing. Okay, this should work now. All right, can you see the screen that I'm sharing, Andrew?
There we go.
Okay, so I'm going to, because you guys heard that, and I'm gonna start here.
25 going to be? Well, this is the number that times itself is going to be equal to 25, or the number where if I were to square it, I get to 25. Well, what number is that? Well, that's going to be equal to 5. Why? Because we know that 5 squared is equal to 25.
Just as I got
now, I know that there's a nagging feeling that some of you might be having, because if I were to take -3 and square it, I would also get +9. And the same.
Let me stop here. And you guys may be confusing, or you are confused on what he just said. So you guys are wondering, well, how is that a +9? Shouldn't that be a negative? Well, No, it's not, because a negative number times a negative number, it gets you a positive answer. It does not give you a negative number. So you need to remember that. I wish I could write it up here. So remember that, you guys. A negative number times a negative number equals a positive number. And it is like that every time. You will not get a negative number. This will not be a negative 9. No. You will not get no negative answers. Okay? So please remember that right there. I hope you wrote that down, what I just said. I'm going to say it again slowly. A negative number times a negative number equals a positive number. You got it? All right.
No, you might want to say it again for the people in the back.
Yeah. All right. Pay close attention. Pay close attention, 8th graders. If you didn't get it, have your pencil ready. A negative number, I'm going to stop, times a negative number equals a positive number. Hopefully you got it. If not, then you will mess up in your answers. All right, let's continue.
Same thing, if I were to take -4 and I were to square the whole thing, I would also get positive 16, or -5, and if I were squared, I would also get positive 25. So why couldn't this thing right over here, why can't this square root be positive 3 or -3? Well, depending on who you talk to, that's actually a reasonable thing to think about. But when you see a radical symbol like this, people usually call this the principal root. Principal root. Principal square root. Square root. And another way to think about it, it's the positive. This is going to be the positive square root. If someone wants the negative square root of 9, they might say something like this. They might say the negative. Let me scroll up a little bit. They might say something like the negative square root of 9. Well, that's going to be equal to -3. And what's interesting about this is, well, if you square both sides of this equation, if you were to square both sides of this equation, what do you get? Well, anything negative squared becomes a positive, and then the square root of 9 squared, well, that's just going to be 9. And on the right hand side, -3 squared, well, -3 times -3 is positive 9. So it all works out. 9 is equal to 9.
I hope you guys was paying attention, because I just mentioned this a few minutes ago. A negative number times a negative number gets you a positive number. This is how you're supposed to be doing. You will not get down here a -9 and right here a -9, because -3 times -3 does not get you -9. It does not. It gets you a positive. So I hope you was listening and you are taking notes. Let's continue.
And so this is an interesting thing. Actually, let me write this a little bit more algebraically now. If we were to write the principal root of 9 is equal to x. There's only one possible x here that satisfies it, because the standard convention, what most mathematicians have agreed to view this radical symbol as, is that this is the principal square root. This is the positive square root. So there's only one x here. There's only one x that would satisfy this, and that is x is equal to 3. Now, if I were to write x squared is equal to 9, now this is slightly different. X equals 3 definitely satisfies this. This could be x equals 3, but the other x that satisfies this is x could also be equal to -3, because -3 squared is also equal to 9. So these two things, these two statements are almost equivalent, although when you're looking at this one, there's two x's that satisfy this one, while there's only one x that satisfies this one, because this is a positive square root. If people wanted to write something equivalent where you would have two x's that could satisfy it, you might see something like this, plus or minus.
Okay, so I just want to explain this down here. You could get two answers possibly to this because they're both are correct. 3 times 3, well, 3 to the square power, which is 3 times 3, it gives you 9, correct? Yes. And then over here, you have -3 squared, which gets you -3 times a -3, gets you a positive 9 as well. So you will get both answers. Either one is correct. Either one is correct, you guys. I just wanted to point that out right there.
Minus square root of 9 is equal to x, and now x could take on +3 or -3.
Okay, so let me stop that there. How many minutes? Because I know it was 13 minutes. So how many minutes do I got left?
You got about 8 minutes left.
Okay, I could do this in 8 minutes here. All right, now, so you guys, let's continue on with our notes here. Where is my share button? Okay, here we go. Now, this is what pretty much he was saying here. These are just some more notes, you guys. Just take a screenshot of it. Take a picture of it because this is not what I want to cover in the next 8 minutes. So take a quick picture of this very quickly because it's basically what he was saying and then I was saying. So moving on, stop share and go on to the next one. Okay, so our next notes that we have, square roots of perfect squares. And then you guys, I have another video of perfect squares, but we don't have time for that. So I will do that Friday. So let's start by taking a look at an example of a square root of 25, which he just did in the video. So the square root of 25, what does that equal? Well, we already know what that equals, but I'm going to show you guys how to get to that answer. So step 1, ask yourself, what number squared equals to 25? Okay, so that's the first step that I want you guys to remember. Then our next step, and I know you guys are going quickly here, trying to get this in. Step 2, notice that the 5 square equals 25. Because it does, you guys. 5 times 5 is 25. And 5 squared, that equals 25. It's the same thing. Same thing. Now, if we go on, just as I just got through saying, you guys, 5 squared is 5 times 5, and it gets you 25. Now, your answer is, of course, it's 5, you guys. It's 5. This is not complicated. This is so very simple if you know your multiplication facts. Because if you don't, you guys, then I'm sorry, I can't help you with that. I'm sorry. Once you come to 8th grade, you need to know your multiplication facts because I will not reteach it again. And I'm not going to do it here. That's point blank. I'm not going to. You should have learned this when you was probably like in 3rd, 4th grade, and you should have really in the 5th grade. And so you'll be all caught up now. So if you don't know it, please know it, you guys. Now, moving on, I just have to say that. Now, here's a question, you guys, to make you understand this. Well, how can we be sure that 5 is the right answer? Well, here are some choices that I pick. And you guys, well, I know you guys are not literally here with me. It's just me and Andrew. But how can we be sure that 5 is the right answer? Well, let's look at A. Because 5 is half of 10. I don't think so. That is incorrect. Let's go to B. Because 5 times itself equals 25, like I was saying earlier, and what the man was saying in the video, 5 times 5 equals 25, and then 5 squared equals 25. Okay, so that seems correct to me. Now let's go to C. Because 5 is an odd number. Okay. Yeah, we know it's an odd number, but that has nothing to do with what I'm talking about. So that's incorrect. So your correct answer is B. You guys, I can't make this even harder than this. This is so very simple. Very simple. Okay, moving on. And I know Tom.
They will trick you. This type of question will be on a standardized test.
Yes, you guys.
They will trick you.
Thank you for saying that, because yes, on standardized tests, you guys, on state tests, yes, they will trick you, you guys, just like this here. They will trick you into the wrong answer that seems correct. They will try your best, you guys. So I'm gonna show you guys how to get the correct answer. I got 2 minutes left. Okay. So I'll talk about this later on into the weeks ahead to get you guys prepared. Now, we're going on to connection to a square. So finding the square root of 25 is the same as finding the side length of a square with an area, okay? Now, I have an example here. Now, you see that I have in my lovely box that I made, inside of it, the area is 25. And on the outside, we have some question marks. We need to find those answers, which we already know is 5. But how? How are you getting 5? Well, my 8th graders. A square with an area of 25 has a side length of 5. So this, hold on. Whoa. This becomes a 5. This right here becomes a 5 because 5 times 5 is 25, you guys. You guys, this is so very simple. It is so simple. Now, this last part that I have for you, and let me take this off. Which claim shows how square roots work? Well, you see in claim 1 that 7 squared equals 49 because 7 times 7 is 49. And the square root of 49 is 7. Then you have on the bottom claim 2, 7 squared equals the square root of 7. So, that's your lesson for today, my 8th graders. I hope that you know how to do this, you guys. I can't make this even harder, you guys. I can't. It is so very simple. Now I'm gonna keep saying again this week. With these problems, you guys, you have to know your multiplication facts. You have to, because if not, then this is going to be hard for you. It is. And for the rest of
I do want to say Notice how he says multiplication facts, and I say multiplication tables. Okay, if you're from my state, we all know it's called multiplication tables because that's how we learn. But if you're from a different state, I'm pretty sure y'all call it multiplication facts. So just know that multiplication facts and multiplication tables is the exact same thing. Because I'm pretty sure what you did in third grade was to it's the ice to feel how many multiplications that you can do in under a minute.
Mm-hmm.
You gotta be on it.
Yeah.
12 times 12 is 144. 11 times 11 is 121. 10 times 10 is 100. 9 times 9 is 81.
Yeah, we could go on and on, you guys. But
Go
again, my 8th graders and the 6th graders as well, know your multiplication facts. Please know them. Before you hit high school.
Please no.
Because if you don't know them, it's going to be hard for you. It is going to be hard. And this is not always going to be with you. You are not always going to be using your calculators. On state tests, on some parts, you will not be allowed your calculators. And your teachers will not allow you with your calculators in class on a type of problem or activity that they are doing. So you have to know your basics. I'm sorry, I just had to say it.
You better know your multiplication. So
so that's my lesson. We will be doing this again on Friday. Friday. I will start with perfect squares that I didn't introduce today. I will do that at the beginning of Friday, and then we're going to hop right into cube roots. So be ready for that. Be ready for that, guys.
And for my 6th graders, we will do part 2 of ordinary pairs and relations on Friday, where we will talk about domain and range. Come on down. That's what we're going to talk about on Friday, as well as words, equations, and tables. On Friday, we're going to be done. Well, actually, technically, in the next 2 weeks, we are going to be done with the language of algebra unit. We're going to be done with that unit, and then we're going to move on because I got some plans to do for you guys. So once we're done in the next 2 weeks, we're done. We're not going to go back to it. We may go back to it as a review, but after that, once we do part 2 a review, after that following Monday, we're done. We are done. So.
All right. So you guys, I hope that 6th graders took notes from your lesson, and my 8th graders took notes from my lesson. And we will be back again on Friday, and we will be back next week, and a week after, and a week after, you guys. So tune in with us, you guys, if you can, during our sessions that we do Mondays, every Monday and Friday at 7 p.m. Eastern, 6 p.m. Central. And if you cannot, it will be uploaded on our YouTube channel.
Y'all already know the motto is same grind, same time, but a different lesson.
Yes. Yes, yes, yes. So I guess we're probably going to end this now unless we are going to go into our office hours. But if not, then we will end this. All right. So thank you guys for tuning in with us. And we will see you guys back here on Friday for another lesson from us. So until then, you guys take care and stay safe out there, you guys. We'll see you back on Friday.
Take care.